Good morning, all of you. I am Assistant Professor Kuti Akshada from S&D Engineering and Research Center, Yeola. Our today's topic is Spectroscopic Technique. Introduction to Spectroscopic Methods of Analysis. What is spectroscopy? The study of the interaction between electromagnetic radiation and matter. That is called spectroscopy. Spectroscopic analysis. These are two types: atomic spectroscopy and molecular spectroscopy. To understand spectroscopy, we must understand electromagnetic radiations. What is electromagnetic radiations? It is a form of energy that has both wave and particle properties. For example, ultraviolet, visible, infra, microwave, and radio wave. Wave properties. Electromagnetic radiation is conveniently modeled as waves consisting of perpendicularly oscillating electric and magnetic fields. In this diagram, these are the direction of propagation: magnetic field and electric field. At 90 degree to the direction of propagation in an oscillation, the electric field. At 90 degree to the direction of propagation and 90 degree from the electric field oscillation is the magnetic field oscillation. Introduction to spectroscopic method of analysis. Wave parameters. These are the diagram of wave parameters. In these wave parameters, on x-axis time or distance and y-axis electrical field. The Quality Control Department of Industries requires the raw materials, finished products of very high purity, which cannot be estimated by the conventional methods. Further, the trace elements in soil and metals, hazardous chemicals in soil and water, the small quantities of air pollutants, impurities in finished products are at the ppm or ppb levels, and their quantitative determination requires sophisticated method of analysis satisfying the demand, using electromagnetic radiation as a probe to obtain information about atoms and molecules that are too small to see. Various analytical instruments and techniques of analysis for the analysis at ppm ppb level are UV visible spectrophotometry, IR spectrophotometry, atomic absorption spectrophotometry, chromatography, nuclear magnetic resonance spectroscopy, X-ray spectroscopy, many electrochemical techniques, and mass spectroscopy. All these methods are certain electromagnetic radiations, and the analysis is based on the principle of selective absorption from the electromagnetic spectrum. We use symbols to designate the various properties of waves. Lambda is the wavelength of waves, V is the frequency of waves, and C is the speed of light. Definitions. Period. The time required for one cycle to pass a fixed point in a space. Frequency. The number of cycles which pass a fixed point in space per second. Amplitude. The maximum length of electric vector in the wave is called as amplitude. Wavelength. The distance between two identical adjacent points in a wave is called as wavelength. That is usually maxima or minima. Wave number. The number of waves per centimeter units in units of centimeter inverse. It's called wave number. Radiant power. The amount of energy reaching a given area per second unit in watts is called as radiant power. Intensity. The radiant power per unit solid angle. The relationship between these variables: speed of light is equal to wavelength into frequency. C is equal to lambda V. Lambda is equal to C divided by V. V is equal to C divided by lambda. For electromagnetic waves, the speed c is a constant. C is equal to 3.00 into 10 raised to 8 meter per second is equal to 300x 10 raised to 10 centimeter per second. This constant speed means a direct inverse relationship between wavelength and frequency. Lambda directly proportional to 1 upon V. The higher frequency, the shorter the wavelength. The longer the wavelength, the lower the frequency. The relationship between frequency and wavelength. Infraradiation, V is equal to 3.75 into 10 raised to 14 second inverse. And in second ultraviolet radiation, V is equal to 7.50 into 10 raised to 14 second inverse. Wavelength is inversely proportional to frequency. Practice properties of light photons. Wave theory failed to explain phenomena associated with the absorption and emission of radiation of radiant energy. The EM is viewed as a stream of discrete particle or wave packets of energy called as photons. We can relate the energy of photons to its wavelength, frequency and wave number by E is equal to HV is equal to HC divided by lambda is equal to HCV. V is frequency, lambda is wavelength and V is wave number. H is a Planck's constant. The electromagnetic spectrum. On the screen, these are the electromagnetic spectrums. Wavelengths, frequency and energies of some regions of electromagnetic spectrums. Some spectroscopic methods have a few limitations. Extremely pure sample required. Instruments are quite costly. High skilled technicians are required to work on the instrument. Spectroscopic method of analysis require small quantity of highly pure sample. Impurities in sample may interfere with the absorption of the waves and may mislead us regarding qualitative and quantitative analysis of sample or may give wrong results. These are regions of the UV visible and IR spectrum. UV region wavelength range is 180 to 380 nanometer. Visible region 380 to 780 nanometer. Near IR is equal to wavelength is 0.78 to 2.5 micrometer and mid IR is equal to wavelength is 2.5 to 50 micrometer. Thank you.